Hello students, in today class we will study about side effects. Okay, so in the previous example we have seen about the data dependencies, okay, and how it affect the data hazards, and also there are explicit and easily detected uh, data dependencies, or we can easily detect the data dependencies in the previous examples because the registers involved is named as the destination in instruction I1. Let me write it again. Instruction I1, we are doing add sorry, that one was mult R2, R3, R4, and I2 is your add right R5, then R5, R4 and R6. Okay. So you can easily detect that in the instruction I1, R4 is the destination, which content we have to change, or we are changing by executing this instruction. That means after the execution of this multiplication instruction or I1, the R4 content will be changed. Okay, and in the I2, R4 is the source. Okay, so in the data dependency, in this example, data dependency can easily detectable, but in some cases an instruction changes the content of a register other than the what this destination. Okay, let me write it. Sometimes an some instruction changes, will changes the contents of a register other than the one named as the destination. Okay, for example is your auto increment or auto decrement. Okay, these two, in these two addressing modes is the example of this, that when we are using the auto increment addressing mode, this instruction will not change the destination, it may change some source operands. That means after incrementing the source operand, then we will add with some other operand, and then it will store in the other register. Okay, so by this, to storing new data in its destination location, the instruction changes the content of a source register that is used to access one of its operands. For example, if we will auto increment this R3 and then what we will do, then it will be added with the R2, then both will added, then it will store in the R4. In that these cases, what the instruction changes other registers rather than the destination. Okay, and other examples are like push and pop. Okay, it produces similar side effects because they implicitly use the auto increment and auto decrement addressing modes. Okay, like in the push operation, when we are incrementing and we are incrementing the top. Okay, suppose in a stack, let's take an example of stack. Okay, so let's one is full and another one is empty. Okay, so when we are adding something into the stack, let it is 1, we'll add, then it is not empty. Okay, then what it will do, that the bottom will be incremented by 1. Okay, and what, let's the size is 5, sorry, here is 4. Okay, 1 2 3 4. Okay, the 4, and if it equals to 4, then the stack is full. If it is equals to 0, then it is empty, like this. So it will be incremented and it is decremented when we will push, and when we will pop, okay, it is incremented and it is decremented. So auto increment and auto decrement uses implicitly or by the push and pop operation, push and pop. Okay, so another side effect is that the condition code flags. Another one is your condition code flags. Okay, so which are used by instructions such as conditional branches added with carry. Okay, like this. Let me write it here, some example that I have already told it in other lectures. So the conditional branches add with carry, then negative, okay, and then 0. Okay, so there are some code flags are there. So let's there are two registers R1 and R2 hold an integer that we ask add to another integer. Okay, in R3 R4, let it is double precision number. In the double precision number we need two registers as the size is more. Okay, so then what we'll do, we'll write like this: add R1 with R3, then this will be carry, sorry, there is no gap, add with carry R2 R4. Okay, and it will be stored in the R4. R4 is the destination part. So here the dependency exists between these two instructions through the carry flag. Okay. And this flag is set by the first instruction. Okay, first instruction, and used in the second instruction which perform the operation this carry. Okay, that instructions having the side effects give rise multiple data dependencies, which leads to it what multiple So for this reason, instructions design basically designed for execution on pipeline hardware should have some few side effects. Okay, and so only the content of the destination location, either a register or memory location, should be affected by any given instructions. So side effects can be of many types, or it can comes from any type of instructions. Okay, but we have to kept the side effects to a minimum level, okay, by introducing different solutions like hardware design, like what, like better hardware design concept, or okay, or like our doing the upfront forwarding concept, any other concept are there. So this is all about the side effects of the hazards. Okay. And the hazards can be solved by using upfront forwarding and by the softwares. Okay, so in the coming classes we will study details about all these things. Then thank you.